These two problems were in a group of problems dealing with the function f, which is 1/8 x minus 4, and the function g was x cubed. And then on the side, I have my work for finding the inverse functions for those two individual functions. So the inverse of f would be 8x plus 24, and the inverse of g is the cube root of x. So looking at 108, we have the inverse of g with the composite of the inverse of g. That's how you say that. That little circle is the composite symbol. And then outside, it has a -4. So when I look at these problems written in this form, this notation, I generally just like to change the notation so that it has like the set of parentheses so I can see what's inside versus what's outside. So I would rewrite this as the inverse of g with the inverse of g and then of -4. So the first function is outside, and then the second function, it happens to be the same this time, is inside. And then there's also a -4. So looking at this, let's talk first about that -4. Jack, what does that -4 represent in our problem? This guy right here.
Uh, the X.
Yeah, that represents x. So in most of the problems, it's f of g of x or g of f of x. So the -4 represents x. So if I start evaluating this problem, we have a -4 that we're going to replace for x. Well, that -4 goes in the inverse for g because I'm using my inverse function for g. So I have the one outside. And then I have the cube root of x. That's my inverse function. Well, if I have the cube root of x, I have the cube root of -4. So that would be the first step. Does anybody know what the next step would be? So now I still have the inverse of g, and then inside we have that cube root of -4. Darby, what do you think you would do next?
So you would have to cube root that whole thing again because you're using the inverse of g's function.
Yeah, so we're essentially taking the same function and plugging it back into itself. So she said this would be then the cube root because that's the inverse function. And then we still have the cube root of -4. Darby, do you know what that means? Like, what could we do with this?
So I didn't know like whether or not we were supposed to solve it, so I just put it in my calculator
And
and
you got
got
a decimal
one
value?
yeah, 1.1665.
Okay, so she said she placed it in her calculator and got a decimal value 1.1665. Did anybody else do anything different with it?
I just kind of changed the way it was written.
Okay, Peter, how did you change the way it was written?
So I did cube root of -4 to the 1/3.
Okay, so this outside cube root, if you remember, we can change a radical to an exponent. So if it's a cube root, it's really an exponent of 1/3. And then, Peter, what else could you do?
I kind of just entered it in my calculator from
And
there.
then
I
you
didn't
entered
really
it in your
know what to do.
calculator? That's fine. Yep. And then you could enter it in your calculator as well. I
Um,
could continue to change it though if I wanted to keep it exact. I could continue to change it. So we said that the cube root is the power of 1/3. Well, that's the outside, so that represents this. But we still have this cube root, which is, again, the power of 1/3. So now I have -4 to the 1/3 power, because it was the cube root of -4. And then that's to the 1/3 power. If I wanted to keep this exact, that -4 would be to what power? What exponent would the -4 have?
1/9.
The 1/9.
1/9, yeah. So really that's saying -4 to the 1/9. Now, did we review that this year? Nope. But we have worked with exponents a little bit here and there. And you could have just converted it and kept it as -4 to the 1/9, or making it into the calculator and plugging in that actual value. Any questions? So again, the unfortunate thing about pre-calc is it relies heavily on all of the concepts from algebra 2, and like just pulling in those facts and properties, and it's a lot. So that is the unfortunate thing about pre-calc, and you're going to find the same thing with calculus. It relies on all of the pre-calc and the algebra 2 concepts. All right, so let's look at 109 as well. 109 wants us to take the two functions f of g, and then the -1. This here is notation. So it's a little weird. Here, that's an exponent of 1/3. But over here, that -1, even though it looks like an exponent, that's the notation of the inverse, because we have functions inside. I don't have numbers or variables, it's functions. So when you see the -1 on the outside, you can't think that that's like a -1 that I would distribute through the parentheses. That little -1 represents notation of an inverse function, because I have functions inside the parentheses. So when we go to look at this problem, if there are parentheses, PEMDAS says work inside those parentheses. So again, changing the way this is written, the parentheses really mean f of g of x. That's what the parentheses mean. And then the -1 part says we're taking all of that and we're finding the inverse. So it doesn't mean that I'm applying the exponent, but it means I'm going to take the inverse of whatever's inside. And I know that's weird to think about a -1 being an exponent versus being an inverse. But when it's with a function, it's an inverse and not an exponent. So Jeremy, if we have f of g of x, what are we using to find f of g of x?
The original equation.
Excellent. So we're using the original equation. Notice there is no -1 attached to either of those functions, but it's separate on the outside. So going back, we're going to use the original equation. And Jeremy, what do you get when you use the original equation?
1/8 x to the third minus 3.
Nice. So you're taking x cubed, replacing it in the f equation. And then Jeremy, what do you do with this equation?
What do they do?
You find the inverse.
You find the inverse, yeah. So again, we took the x cubed, we replaced x, and now we're finding the inverse. So we're using this new equation, which is our composite, and we're finding the inverse of this composite equation. That's what the little -1 means on the outside. So switch x and y. And then I need to get y by itself. Just be careful when you're multiplying by the 8, make sure you take it to everything. And then I need to take the cube root to get rid of y cubed. So my inverse of the composite function. So I took the composite function of the initial f and g functions, and now we're finding the inverse. I would end up having the cube root and then 8x plus 24. Does anyone have questions on that? So we used original functions first because inside the parentheses were the original functions. The -1 on the outside represents the inverse of those original functions. So combining the functions together using the composition of those functions and then finding the inverse. So essentially, if the inverse is attached to the individual function, then you use the individual inverse function first. If it's on the outside separate, then we're using the regular functions first.
Dude,
Question.
you're so not good.
Parker, question?
No.
Anyone else? Darby, question?
No, is my hand still raised?
Yeah, I took it off, so it's
Oh, okay.
yeah.
Okay, sorry.
That's no problem. No. All right. So then if I just keep scrolling, somewhere is the review. There it is. So the review worksheet starts way back from the first section, kind of talking about functions. Is something a function of x? And it's a function of x because x's are independent variable. So here it says which of the functions is, or which of the following is not a function of x. And in order to determine if it's a function, the easiest thing you can do is get y by itself. So you're trying to figure out which one is not a function, get y by itself. In number 2, here is that difference quotient. There will definitely be a difference quotient problem on the test, and we'll continue to work with these. But just to start you off here, remember you're using the function and applying the difference quotient to the function. So I have 1/2 x. Well, x is now x plus h. That's what that first part means. So f of x plus h means use the function f and replace x with x plus h. Then I have to subtract f of x. Well, I'm subtracting f of x, which is 1/2 x, and then we're dividing by h. So if I distribute, the common piece of all of these difference quotient problems is that I should have terms that cancel. So my x terms cancel. And then I'm left with 1/2 h over h. And again, that term, the denominator, will cancel every single time. So my denominators cancel and I'm just left with 1/2. But don't forget, it says it in the initial problem, h can't equal 0. Make sure you state it in the answer as well. Number 3 wants you to find the equation. We talked about writing equations of graphs. So write the equation first, and then you have the graph drawn for you. So find the domain and the range of the graph. And then number 4 wants you to get the intervals of increasing, decreasing, or constant. So where are they increasing, decreasing, or constant? This doesn't give you an equation to work with. So you're going to have to use your best estimation of getting those max and min values. And then 5 wants you to, again, find the domain of the function. So thinking the domain, the denominator cannot equal 0. So factor first so that you can get the 2 values in the denominator for x, which it cannot be. So that was a little review of those first 5 problems. As I said, today is really a time for you to work on the homework, and then any questions that you have, circle them, write them down, put them in the margin, put them on a sticky note, remind yourself so that you have tomorrow as like question and answer time. But the last 2 sections that we've talked about, the inverse functions and then the combination composite functions, those would be like the newest material that we were covering at the end of last week and the beginning of this week. But it's an entire chapter 1 test, so it's on all of the concepts that we've looked at. So I will be here. You can choose to stay. You have 20 minutes. You can feel free to leave and work on this worksheet and then pop back in if you have a question. It's totally up to you. But if you were in class, I'd just be walking around, checking your work, looking over your shoulder and seeing if you're doing the problems correctly. So I'm still here. I'm not looking over your shoulder, but I will be here to answer any questions that you have as you're working on this worksheet. Does anyone have questions?
No. All right, so if you want to leave, have a great day. Again, I'll be here if you still have questions.
Thank you. You too.
Yeah,
Thank you.
see you
Have a
later.
good day.
Have a good day.
Bye, Miss Kane.
Thanks, you too. See ya.